Hello and welcome to the not live stream that we're sending out today after some technical issues down here at the wonderful, let's bring it in, the wonderful Doncaster Cables. This is our 7th stream and we've got a few technical issues that we're going to work our way through, so hence this isn't live, but we still want your comments and we'll get back to as many of those as we can. So we're down here at Doncaster Cables. The theme of today's stream is those cables that you wouldn't see in a normal college setting. That's what we're going to be working our way through. But before we do that, let's just introduce ourselves. My name's Gary Hayes and I left school at 16, did my apprenticeship over 4 years. What would be tradition way of completing an apprenticeship, including endpoint assessment. And then I went on to teach for 19 years and I've got the absolute pleasure of being part of the eFIXX team. And it takes us to places like this, doesn't it? And yourself?
It does, yeah. So my journey's a little bit different to yours, isn't it, Gaz? Yeah? So my name's Marcus, okay. I'm self-employed electrician at the minute and I obviously come and do these live streams with Gaz where we normally visit colleges. Today we're at Doncaster Cables, as Gaz has said. I retrained as an electrician, so I didn't take the conventional apprenticeship route as such. However, I still had to complete a competency-based portfolio. Still did it that way, okay? So I've got into industry that way. I then went into teaching with Gary. He brought me into teaching, didn't you?
Yeah, I did. Yeah, good fun, wasn't it?
Yeah, it was, yeah. And then left teaching, set up my own business, and now working on the tools as such.
So you've got a little bit of everything in there, and I would suggest if you're watching this stream, I know he said live, it's not. If you're watching this stream, obviously as a person training, fantastic. If you're watching it as an electrician as well, thank you. And please join in the comments, because sometimes we can't get back to them all as quickly as maybe a learner would like, and your experience on site would be fantastic to us. Now, as we're at Doncaster Cables, we've got the legend that is with us, so let's bring him in on his own camera. He's over there half asleep. It's Aaron. You got to say, we're going to do this as if it's live, Aaron, so we're going to have to go over there. So Aaron's going to be our resident expert here at Doncaster Cables. So as we get to those tricky moments in the stream, bringing him in for his expertise. Now, we've got some cables in front of us. Before we sort of look at that EV Ultra cable, which is possibly the last 18 months on Instagram, possibly the most famous cable, isn't it? People love to show their EV Ultra. I've installed a bit of EV Ultra. Well, we're going to go and look at that today, as well as some of the bits we've got here, and another one, low smoke, non-halogen cables.
Yeah, we're going to have a look at that and how they've designed it to maybe make it easier for electricians to terminate.
Talking about making it easier and terminating, you've also got a tool over there, haven't you?
Let's
have a little look at your tool. So here we go, Marcus. Right, okay.
Yeah, so we've got the armour slice.
Okay, so you think that's going to make steel wire armour cables easier to make off. I'm going to just flick my camera up and ask Aaron, do you think it makes life a lot easier, Aaron, just to give us a yes or a no?
No.
And I've never got on with it, but we're going to use a tool that's going to be making life easier. Again, in the comments, if you've got that tool and you're an expert with it, please put it in. If you've used it like Gary and called it the toffee twister, I can't get on with it. I've only done a few, though. I'm an occasional stripper. Yeah, occasional stripper of an armoured. Okay, so that gives us a tool, but we said we were going to be talking about cables, and we've got some cables in front of us. I noticed down here, let's have a little look at your satellite cable. So you've got a bit of satellite cable down here.
So that's a cable. Satellite's in the industry now, isn't it? Everyone's installing satellite.
Okay, so that's a cable you wouldn't see at college, the old satellite cable, but is it?
Unfortunately, it's not satellite cable, Gaz. As much as it looks like coax, okay, this is solar shore, and this is what we'd conventionally use with a PV system connecting our strings, and you generally see it laid in a loft, clipped in a loft.
Yeah, but that becomes a bit of a concern to me. So I'm up in the loft, and I've noticed a couple of black cables. I'm thinking I'll get a bit of Sky TV into one of the children's bedrooms.
Yeah.
Are those cables live in daylight?
Oh, well, they will be. And there's no way to switch them off, unfortunately. Or very restricted ways to switch them off.
Just turn off the sunlight. Okay, so of course there must be some issues with that cable. A cable that we're not seeing currently at college, the one for solar PV, but I think it's coming, folks. I think as the syllabus is developed, you're going to have a touch on solar cables, MC4 connectors, etc.
Yeah, 100%.
But it has to be labelled, doesn't it?
It's very important that, especially when you're installing this in a loft space, it is labelled to show that it is a live cable as such with DC. And it's part of the solar system, so you don't have, and it's not like we'd label it at one end where the strings are connected and then where it exits the wall, etc., or where it connects to the inverter. It's important we do that for its run so that we don't have that issue, because the last thing you want is nice summer's day in July or August, someone goes and thinks, oh yeah, I'm going to, like you said, put TV into it, into a room, cut through it, and it wouldn't be a very nice arc, would it?
No, and it can be up to 1500 volts DC. And when we're talking about voltage and bands of voltage, that will link to something later on in the presentation. So we've got some tails down here. These are the old conventional ones, so we get those out there. And at college, you're unlikely to be using meter tails really when you're installing your basic
not very
light
often,
circuit.
is it? With that, you're generally going to maybe be using a piece of flex to connect in to turn your lighting circuit on or energise it, aren't you? So
yeah, absolutely. And there's is there 7 cores in this one?
there is 7 cores,
and it's 25 mil. And when students get a hold of this, it becomes a bit of a wrestling match, doesn't
it? It does, yeah, and they feel strong, don't they? They bend it around. Oh, look at me,
big butch cable. Okay, trying to move it around, but for us, repetitive strain, trying to bend it into consuming. It's in a very difficult small space.
Especially if you're changing and consuming it over, and you've had tails that are 25 mil, and they're in there, and you're using the existing tail. Sometimes you can find out because they've had current through them for years, they've got a bit stiffer and not as pliable. So is that the right word?
Yeah, it is the right word.
Would Joe be happy with that word?
Joe would be happy with pliable. And this one seems a little bit more flexible.
Favourite, have a look at that one. This is what I use on site all the time. We often refer to them as flexi tails.
Okay.
And the main difference, if you can see, obviously this outer PVC sheath is actually coloured to the colour of the conductor.
Okay.
But if you look, there's actually 19 cores there, which helps to give it its flexibility.
Okay, so that's 19 core compared to 7. They're both 25 millimetre squared, so there's no issues there with the diameter. So current carrying capacity, look at that, bend it around, it's super flexible.
It is lovely.
Again, a cable you're probably not going to see necessarily in a college setting.
No, generally because you don't see 25 millimetre towels anyway, do you?
But when you see it in the wild, when you're out there in the wild, you're like, wow, I'm so glad I found this 19 core. And that's made down here at Doncaster Cables with us. And then we've got some other standard cables we're used to seeing. We've got our twin and CPC, often called incorrectly on site, twin and earth cable. Okay. And we've got this one here, which is a little bit odd as well. Don't hold that one for me. Well, that looks... It's a bit different. I don't really see those very often.
No.
So happy with the colours. I like the fact that we've got a 3-core, which is not an armoured cable. It's a tough sheath, isn't it? Tough sheath
it is.
cable.
And they've used brown, blue, and green and yellow rather than the brown, black, and grey, like you would see in a generic armoured cable. So.
Okay, and then there's a little 2-core one here.
Yeah, a little 2-core.
Okay, and we're going to touch on why these cables are so important to us now as electricians. But again, a cable that we don't see in the wild in a college very often, but we're out there on industry, we're likely to come across those type as well.
And it might be some apprentices still haven't come across this because their employers are just breaking into a certain part of the industry or just going and training themselves in it. So again, an important cable for employers, electricians and apprentices to see as well.
Okay, got a scroller now. My good friend on Sunday, Rick Gaunt, okay, we know as eFIXX Rick, if you're following on Instagram.
Yeah.
I sent a message out through an email, which is a rare event for me, and asked on Monday for him to create something for me, but he didn't create it on Monday, he created it on Sunday. So let's bring it in. Here we have our thank you very muches. So the people that are supporting me on the eFIXX College Connections and monthly on these streams, let's drop the word live this year, we've got the following sponsors helping us bring this to you every month. We've got Doncaster Cables, we've got Marshall Toughlex, we've got the Lasico Group, we've got TIS, Test Instrument Solutions, we've got Schneider Electric, we've got Wallbox, we've got CNorm, we've got Wago, and we've got Matrel that are all supporting us here to get out into industry and into colleges. And next month we are at a college, so stay on to the end to see which college we're going to. But also you want to stay on the end because we've got some fake cables. You definitely don't see those at college.
No,
so
you definitely don't.
So that'll be later on in the show. Now, we mentioned at the very start of the show, didn't we, that EV Ultra, and I said it was quite popular across social media.
Yeah.
Shall we take a look at when Ross Sands, Rocket Ross Sands to us, was on site? Shall we have a look at the video clip that we had with him?
Let's go have a look at him installing it.
We've used EV Ultra many times on the channel. What I like about it is obviously you've got your colours, you've got your line, your neutral and your protective conductor, and that Cat5 cable inside of the same steel armoured cable.
Yeah, and as you can see here, we're using it in conjunction with a BG Sync EV to install that and utilise that Cat5.
And what's nice is that means there's only one cable on the outside of the building, that's the one he's installing now. The one on the left is actually part of the tethered EV charger. So you haven't got that separate data cable coming out with it.
No, and definitely for the customer's point of view, it's more aesthetically pleasing, isn't it?
Absolutely, and it's quicker to install because look, now this cable's in, we've got both cables in the same position where we need them to supply the EV charger as well as bring through the Cat5 cable, but it isn't being used as a Cat5 in the traditional sense to bring data to it.
No, it isn't. What we're generally using it for on this is going to be a CT clamp. Therefore, as you can see there where we're sorting out the cores, we're actually only going to end up using 2 of them cores in conjunction with the CT clamp that we need for the EV charger.
Okay, so this end we're going to make the 2 connections with that Cat5 standard connections for a line neutral and protective conductor, and then back at the mains end we're having to pick up that CT so we don't blow the incoming fuse, which could be rated as low as how many amps?
It could be 60 amps, Gaz.
Okay, so that gives us that control, so that load shedding, in other words, that when the EV charges on, it knows exactly what's being drawn by the installation and therefore won't blow the cutout fuse, which is really clever that we have that ability to understand how much load current the installation is drawing. Looks pretty neat as well.
It does.
Look, we're catching him out. Look, he's fiddling with his cable over there, and he's looking down. He's not paying any attention. He's over there. So, okay, so yeah, we're on site. We're out there installing these EV chargers. This EV, I've got an issue. I've got an issue, and this is what we need to address, isn't it? That's why we're down at Doncaster Cables, get to the root of it.
Yeah.
I talked for those 19 years. I talk about segregation of band 1 and band 2 wiring systems. So
I think you drummed it into
us. We'd often use the trunking system when we would look at a piece of maybe skirting or dado trunking. We'd have a top compartment, a bottom compartment, and a centre compartment. And we would be suggesting that in the top and bottom compartments, we'd be falling into band 1. And AC voltages, that would be 0 to 50 volts AC or 0 to 120 volts DC. Remember, these internet things are working on DC. And then the centre section would fall into band 2. Which AC voltages were?
We're looking up to 1,000 volts AC and potentially 1,500 volts DC.
Yeah, okay. So but there we go. We've got those, and we'd segregate them. There'd be loads of issues, not only about maybe cross-pollinating the voltages, but also about cross-talks and hums, which starts to interfere in those data cables.
It does, yeah.
So I'm going to take a little bit of convincing, so I think you need to go over there
before
I go and square up to him, and say to him, I don't know what he's playing at over there. His cable can't be correct.
The bottom of this, shall we?
Well,
for electricians around the country.
We should get to the bottom. Do you want to take my microphone?
I will take it over to the expert. Gaz obviously taught me, okay, you've heard my story, and he drummed it into me about the segregation of band 1 and band 2, and then I'm on site and I see this cable and I'm thinking, oh no, what's going on? My schedule of inspections, how can I tick the box to say they're segregated?
Yeah, well, this took us about 2 years to develop. So we took a lot of time to develop the product, looked at all the reasons why we've always been taught to segregate band 1 and band 2. And then we tried to come up with solutions to that which would allow us to combine those together. So one of the main ones is the band ratings. So what we've done, if we're coming closer to the data cable, and there's 2 different data cables that we use, but we've upgraded this data cable so it is now the same nominal voltage as the power conductors.
Ah, okay.
What does that mean then, Aaron? The same power rating? What part of the cable have you updated?
So the way that the cable is actually manufactured, so the materials, the screening, which we've called a super screen. And if I actually flick that round there, you'll see this cable. So a category 5 enhanced super screen data cable. So the materials that we use, the specification of the cable, how it's designed, means that the nominal voltage of this is higher than a normal Cat5. So it's not just a normal Cat5 as you would get in a box. So that overcomes the first one where we've now got the nominal voltages the same. We're then looking at the electrical noise and the hum that you referred to, and this is where the super screen.
The super screen, and this is why it's labelled the super screen, isn't it?
This is why it's labelled super screen. So, as well as some other clever features in how it's assembled. So, as much as the materials and composition of the cable is a big part of it, and the super screen is a big part of it, the actual assembly process is also a massive part. So, how we actually assemble and lay up the conductors with the data, how we then put this bedding round it. And then the sheathing. So we've now got this double encapsulated outer sheathing, inner bedding, and all these components are protecting the cores inside and the data to make sure that there's no interference and that these twist lengths don't change, because that's an important part of the data cable.
Yeah, that's great, isn't it? Because naturally we would think of the screen being the only factor to stop these, the hums as such, but actually what we've got is quite an intricate process where they're laid in a certain way and they're covered in a certain way to sort of stop that from happening.
Yeah, and they all come together, even down to the middle dummy core, the bedding, the sheathing.
Oh, is that what it is? I normally connect that to my earth bar, just in case. I don't really, Aaron, don't panic. Yeah, no, great cable, isn't it? And in terms of, obviously, we're talking about EV, okay? So we might be connecting this to a CT clamp, okay? We might be using it as data. this EV isn't just where it stops, is it?
No, so the one you had before had the 2-core data.
Yeah.
And if we can just bring the camera onto this board, when we first started this cable, it started off down here, and now it's sort of expanded and grown into all these different ranges. So now we're going from 4mm up to 16mm.
Yeah.
We're now covering home offices, garden sheds that are now
and
home offices.
To be honest, that's where, obviously I'm an electrician on site as well, that's probably where I've used this the most. I'm sort of just breaking into the EV side, but actually during the times of COVID, people are starting to work from home a lot more. I found that they have a lot more installs to, like you said, the shed or the outbuilding at the bottom of the garden, and it was always an issue maybe trying to get the Wi-Fi down there, okay, because they go a certain distance, and this has really been a great saviour for me, because I can explain to the customer how we can run it all in one cable. We don't have to run a separate ducting to get one down there. So for me, I've used this predominantly for outbuildings, which, like you've said, is perfectly fine, isn't it? So
yeah, and it's for us, it was all about making the electrician's life easier, like a lot of us other products. But it's just quicker, neater, time-saving device. So what you mentioned there, we've also got gate entry systems as well. So that's another big one where you've got a gate entry system. There's a motor to power the gates, but they need telecommunications, as well as CCTV columns and caravan parks. And it's just grown and grown and grown. And we've added the range in to accommodate where people are wanting to use this power and data together.
Yeah. And as like I said, as an electrician, thank you for saving me time.
That's what we try to do.
Yeah.
Okay, yeah, fascinating, absolutely fascinating that we've got that there then, and that links in nicely if I bring up page 93 of the on-site guide in there.
And, did you sound, is that a book?
It's a book.
It's a book. I think we've done a stream on that, haven't we?
We've said before many times on the streams that the thing to do is buy the books they tell you at college and then to do what with them? Read them. Okay, and this is another classic example, isn't it? There was a big lurch, wasn't there, when the EV Ultra first came out. You can't do this. Absolutely can't do this. But it's a simple case of just reading page, in this case, 93 in the current on-site guide. So if I bring it up on screen then, which bit does your eyes get drawn to, other than the voltages that we've already discussed?
So straight away, I'm looking at indent A, okay, where it talks about every cable is insulated for the highest voltage present. So that way we can get around the need for segregating them cables apart because they're all rated for the highest voltage.
And by design also, it's got rid of the crosstalks and hums as well.
Yeah, of course, yeah. Like Aaron said, it's not just that foil screen, it actually goes into how they bed the cable into the double bedding they've got.
Absolutely. So that's brought that cable in. You probably aren't seeing it in college, but you are, because I'm seeing it on LinkedIn now. Lots of FE colleges have started installing EV, and they've started connecting them together using EV Ultra, which is fantastic. So if you have got it at your college, go and take a closer look at it, sort of like blow that myth out of the water, have a look at it and think, I understand now that's not a standard Cat5 cable. No. The insulation's been right buffed up, and by design will remove those crosstalks. And
it's obviously super screened as well.
Yeah, super screened. And it says it on the side, I think you'll find as well. So that's great, but you spoke earlier on about this cable here. You talked about the cable that we're probably going to call strings, aren't we, when they come out of the roof space with our solar. So let's go over and speak to a good friend of the show. So we'd like to thank the Oval Renewables, and it's Sam Featherstone's in there, and he's going to give us a little bit of a masterclass on the introduction to solar PV.
Yeah, sure.
Hi everyone, Sam from Oval Renewables. I'm going to take you through this little solar PV rig setup that we've got here at Nottingham College. So let's have a look. So we've got this board here, but I'm actually going to start at the panel side of things, which we've conveniently got set up looking out of the window, try and get some sunlight. So I don't know if we can have a little look around there in any sort of ease, if we move that round. So we've got these two panels here. They're looking out to this window, collecting all that sunlight. That energy is being fed through these panels, through these DC cables just here. That goes through and then over to the other side. So let's have a little look at that side. So these come through this board here and into this little Solis inverter. So that energy there is passing through, and that's all DC, so direct current coming from those panels. This inverter's job is to change that DC to AC and feed that through the flex cable here, through this AC isolator. We should probably have a DC isolator here, but we won't talk about that for now. And then we've got another AC cable out of that isolator through into this generation meter. So that little generation meter is just logging everything that solar is producing as a visual reference into our, what is on this little rig, our home consumer unit. That energy is then fed from the solar circuit across the rest of the circuits in that home consumer unit. anything that the system can't use, so if the home is, the customer's out and this is generating loads of power, the power will always go to the home circuits first. Anything left over will be sent back to the grid, and that'll go back into the network, to the neighbours, and all your neighbours will be benefiting from the solar that you're generating. If the solar isn't generating enough, then what it'll do is it'll send everything it can to the home. You might need another kilowatt. That is automatically purchased from the grid. So the home always uses the solar that it can. If it's producing too much, it sends it back to the grid, and if it's not producing enough, like put the kettle on or something like that, then it will top up whatever the solar is generating with grid power. So that's everything. Then we've got a nice little table set up, all the different things that you see as a solar installer. So we've got rail, we've got MC4 plugs, we've got joiners to join these rails, we've got roof hooks that go into the roof to carry these rails, we've got mid clamps, end clamps, we've got an MC4 crimper just here as well to crimp these onto the cable. And that is basically everything, and then some solar edge optimizers as well. Back to you on the live stream.
Okay, so I'm on my own now because over in Toffee Twist Corner, we've got Marcus going to attempt to show us this device that's meant to make making armoured cables off easier, which the jury's still out for me. However, again, it's your comments we want. Is this a tool you've got? Is it your go-to tool on steel armoured? Did you find that when you got this tool, it revolutionised the speed in which you can make off an armoured cable? We love those comments, whether you be an electrician or someone training, especially if you're an electrician and say it's a really good tool. Might be something that obviously a learner or somebody training to be an electrician might want to pick up in the future. But let's go over to him because he's ready to show us whether he can do it or not then, mate.
Toffee Twist Corner, as you call it,
Toffee
Dad.
Twist Corner. Here we go then.
This is not Rick's tool time. Rick, don't worry. I'm not planning on taking over your segment. It's absolutely fine. So we're going to be looking at the armour slice. Okay, again, one of them I found whether it makes it easier on site. I'm still to be convinced. I still use this on site. As you can see here, we've got a little rigid hacksaw blade. We've also got a direction to rotate it as well. Okay, so it's just as simple as sliding it onto the armoured cable. And what I always find is holding your hand there makes it a bit easier, because if you don't, what you'll find is as you try to turn it, what will happen is it will start to corkscrew up sometimes, or corkscrew down. So we're just going to bite it into the insulation, and sometimes...
Is that your elbow squeaking, or is that the tool?
No, that's the tool. Needs some WD-40. So we're just going to keep spinning it, and we tighten it as we're spinning it. Sometimes you tighten it too much to start off with. What happens is it actually catches on the armouring, and then it starts to sort of snag. So you can hear it now.
Yeah. Are you trying that still every time you go round?
Yeah. So what I'll do is I'll wait for that to reduce a little bit before I tighten it up, because otherwise you just start to snag it and it sort of twists the cable round.
It's probably my toffee twisting moment, isn't it?
Yeah. So we can just do that, tighten it a little bit as we're going round. So there's one action, and again, we're all guilty of it when we first use it. We just think, tighten it up, straight round, and yeah. So we're just going to do that, and you can sort of hear it cutting into the armouring.
Okay, and is it down to feel again, like using a normal hacksaw?
Yeah, and I think that's the thing I don't like about it. With a hacksaw, you get that feel. This, you don't really get the feel as much, because you're not putting pressure against it. So you don't get the feel, you're just getting the turning. So that should be enough.
Should. I like the way you say should be enough. Okay, no pressure in, Marcus. We're not going to glam this one up this time around, but again, if that's the sort of video you do want from us on a live stream, we can do it in the future.
We can slide
just leave
that
it in the comments.
If we bring it close up, we can see we've got a nice clean cut in there.
I don't know, I've got all I can...
Can you see it?
Yeah,
Should we take it off?
Yeah, well, let's proofs in the pudding. Oh, you're going to try and pull it off. Oh, I like it. So none fell on the floor, which is always a good sign, I think.
Yeah, because it means you haven't gone too far through. And then what we're going to do.
Right, let's see how many times you have to wiggle that. No, that's not too bad, is it? 4 out of 10 at the minute for me.
4? Just a 4?
Yeah, there we go.
There we
So
go.
look at these ends, just check they're not hooking over at the end. A little bit of hooking, a little bit of bending on the end, which makes it difficult to put the gland on. So
It does.
here we go again. So, okay, yeah, mildly convinced me, but again, I'm occasional armoured maker offer now, so it does become
And again,
a
yeah,
little bit challenging.
like I said to you guys, I don't always use this. It's whatever I can get first in my toolbox.
Okay, so first tool out's the one you're going to use, yeah? So let's see you pull those off. So, okay, so nearly there. So again, comments, is it a tool you like? Is it a tool you don't like? I'm not a fan of it, but I think that's down to actually not knowing how to use it properly. You seem to make that look really easy. Let's have a look from there.
You see there? So it gives you quite a nice cut.
Okay, yeah. Still a 4.5 out of 10 now.
Yeah.
I think no better place to start maybe than me doing a bit of a demo. We've seen the Marcus do one with the armoured. So there's a low smoke cable there. Is it made by Doncaster?
That one is not.
Okay, so let's give this one a go then, so we get a comparison between maybe what is happening out there on site. Now it's white. Back a long time ago, white PVC cables tend to be a DIY thing, but now when we see white, we know it's this low halogen. And we're going to go into what low halogen is in a minute. So simple technique for me, it's always the way. You just snip straight down the middle, hopefully, and I'll just separate the conductors, and then I just roll my knuckles like that. Just roll my knuckles. Just roll my knuckles.
Just right.
Okay, just so again, I've never ever been a fan of doing this, which is obviously taking the CPC. I think I've caught it slightly. I think it might break. Yeah, it broke, so I'm gonna have to try again. Let's try that again. So in we go. Never ever break them. God, I'm losing my touch. There you go, I didn't break it that time. Okay, so I'll get my protective conductor, and I would never be an advocate of this at college because very small lengths of cable, what people used to do was pull it forward, or backwards I should say, so they'd go, rather than pulling it up, they'd pull it this way, and they'd bring me it out of the cable and say, what do I need to do now? So I wouldn't need to replace the cable. So if we were trying to do that, wow, hang on, you're having a laugh. Okay, yeah.
Right.
I might need to sit down. Are you for real? Wow. That is difficult.
So
Can't even peel it off.
This one's a bit of a mixture. So the low smoke non-halogen cables are more difficult to strip anyway.
I hadn't noticed.
The nature of the compounds. What we've also given Gary is one that's not made very well. So what Gary's struggling to do now is actually separate the cores from the sheathing. He's almost got there. We'll wait.
It's dull. Yeah, no problem there. I can't see how anyone could improve on that. Wow, that was awful. To be honest, that was awful. And I can see why people are not fans of this. Obviously, we're in a lovely ambient temperature in here as well. We're about 22, aren't we, in this room? Obviously,
Yeah.
we're not. It's not freezing cold on site, which I'd imagine makes it a little bit more difficult. But there's ways to improve stuff, isn't there? It's simple, almost a commodity product in the case of twin and CPC cables. But we've got the low smoke variety, and you've got a way of making it easier for electricians to use it, haven't you?
Yeah.
So let's find your cable then. So your cable is...
Our design is over there.
Okay, I'll find that. So let me just grab that for you. So let's have a quick look at it. So...
Just come in close.
Has that got like a little groove in it, hasn't it?
Yeah, that's yeah.
Okay, groove down there. What's the thinking behind the groove?
So the idea behind this is just to make the electrician's life easier again. So this groove, depending how you strip the cable,
Okay.
you can either pull the CPC back and you've got less material to pull through,
Ah, right, yeah.
or the way that I prefer to strip them is by using utility knife. And we've now got a really nice groove that goes straight over the CPC.
Okay, away from
And
your
not
thumb
in the
towards
cores.
your chum. Just like to note for the record here some previous attempts. Have a look at his hand just there. Look, some of the previous attempts. We've got one there. But this one was new today, wasn't it? You used a knife today and you caught yourself. So
Call that the arrow.
Yeah.
These all happened before this design came out.
Oh
you
yeah,
see. That's
okay.
what
Yeah.
it
That
was.
was it.
I did that and thought, right, let's make a better
Drive some
64
innovation.
2B.
So you've run your knife down it.
I've run my knife down it, and normally that would be enough for ours, so we could actually peel that around off the back
Okay, that's a lot of pressure. Oh, I like it.
and
Yeah.
around the cores.
Yeah, but you could also pull that CPC again if you wanted
Yeah,
to.
so you could either get the CPC and pull down the score, but you can see that it's still sealed there. I've not actually gone all the way through.
So can we see that, Marcus? That we've actually just got that groove just there. Okay.
But because we've had that nice line to follow, you can either pull the CPC or we can just pull the whole sheathing.
So, and to the
back
point at
to
which
where
you
we
grooved, yeah,
started.
but that seemed a lot easier. And again, the one thing I do love about a Doncaster cable is the white French chalk. It's jam packed full of chalk, obviously making the two separate really easy. And that wasn't easy on that one at all. Right, okay, I like that. So let's have a chat then about low smoke cables. So low smoke non-halogen cables is what we make here at Doncaster Cables. Can you give me some sort of installations that would maybe specify low smoke?
Yeah, so you're looking high-rise buildings, hospitals. It's basically where the means of escape is more difficult than a normal domestic property. So somewhere where it would take a long time to escape or the residents might not know how to escape because they're not familiar with the environment.
And the clue's almost in the name of this one. So it's a low smoke cable. It doesn't mean it doesn't give off any smoke. It's a reduced smoke. What is the problem with the smoke that's given off on the standard grey twin and CPC cables?
So the standard grey twin and CPC cables, you get in a thick, dense black smoke, and it's got hydrogen chloride in the smoke as well, so it's a poisonous gas inside the smoke.
Okay.
So another place where they use is also where there's a lot of electrical equipment, so data centres.
Right.
Not necessarily for fire escapes, but the black smoke that comes off of PVC products, when it comes into contact with moisture, attacks electrical equipment. So expensive data centres, hospital equipment. There could be a fire, black smoke, moisture, but it would damage the equipment that's expensive, so they choose to use low smoke, non-halogen cables in that scenario as well.
And that makes sense. And that's good. I'm glad you explained it to me, because I'd often said to my learners over the years, why don't we fit it in a dwelling? Okay, if it is that much better. But like you said, the amount of people in a dwelling of single occupancy, so we're not talking about houses of multiple occupancy and things like that, or high-rise buildings. But yeah, it's almost sense, and if the building's on fire, is that going to be a contributing factor for not getting out this black dense smoke? Probably not, is it? It's probably a weighing up the argument that no, we can use standard PVCs. And it's a little bit more difficult to work with. It's a little bit more difficult to shape into bends. It's a little bit more difficult to dress, isn't it? So
yeah, there's a lot of that in.
Not fans always, are they?
In just the whole formulation, they put fillers in. The main one being ATH. It's got a posh word, but ATH. But that makes it very brittle and very stiff. So you can actually feel the stiffness of the products and how hard it is to work with. Yeah,
and I remember seeing it on site where people were doing things like that, where they were trying to come round to change direction rather than trying to make a nice flat bend that we taught at college. Actually coming up with different ways of clipping and supporting it, which made sense because I've tried over the years to try and make a really, really sort of same sort of standard job as a grey PVC, and found it incredibly difficult to make it look anywhere near as good. Now, when we talk about low smoke cables, that must link into your Fireshore here cable. So we've used these. Hopefully this is a cable that we are familiar with at college. So this is the ones that we'll be using maybe at endpoint assessments. It's sort of a replacement for mineral insulated copper clad cable, and we love this compared to it because there's less skill involved in order to make it off. But this is a fire cable, so what properties will this have?
So this is also low smoke, non-halogen. The materials are completely different to the low smoke, non-halogen flat twin CPC. So this one's got a cross-linked polythene and an outer sheathing.
Yep.
This one's now all about fire performance. So the purpose of this cable is circuit integrity. So in a fire, we want the integrity of the circuit to be maintained. So this is now silicon, which is quite soft.
Okay, so just try and see that a bit closer up. So this is silicon. Okay, here, so that is soft. Okay, I've got that. That's quite pliable. Yeah, okay. And what happens to this when this actually catches fire? What happens to this material?
So in fire conditions, that ceramifies. So it becomes
ceramifies.
Yes.
Is that a word? It ceramifies. Are you making these words up? It's a Scrabble thing, is it?
It may have been made up, but it's become part of my vocabulary for 15 years being here. I believe it is a word. Ceramifiable is a word, I think.
Okay, brilliant. Love it. Please comment below if it is. Okay, look it up. Ceramifiable, that's easy for me not to say. And that becomes, when it gets that sort of white coating on it, does it, when it catches fire, that is it's holding its fire performance then, isn't it? It's protecting against fire.
Yeah, it turns into a ceramic, a pot, an ash, but it's a brittle ash, a brittle pot, and that actually separates these cores inside.
Yep.
Ours is then a unique design, which we need to make some content on to explain that separately.
Okay, fine. Talking of content though, for lots of stuff is in links in descriptions for things for these videos. We've got stuff on classes, conductors, how twin and earths made, etc. You do this really easy with this tool here. So you're going to strip one off for me. So simply ring round with those.
So yeah, I'm ringing round, and ours is like a flexible, which you will be familiar with. So
oh wow,
we're just doing that, and then we're just twisting it as it comes off, and then it comes away.
Okay.
And the reason we have to twist it is because in the end, if I just cut that again, we don't have any air gaps. So we're filling all this inside, so you get a really robust, strong, durable cable that doesn't kink and doesn't snap. So again, it just makes life easier for the electrician, where they've just got a more robust cable to work with.
And if there was an air gap, could we get to a point where maybe smoke goes down the cable? Could it then transport itself around inside of the cable? Is that a thing that's possible?
It is possible. So this is one of the reasons why we chose this design. So the R&D team, when I was involved with that, there was a fire in London, and the fire actually travelled to a separate building, a separate flat.
No.
Because smoke had gone through the conduit and the fire had travelled through the conduit.
Wow.
So we took that principle and sort of said, well, the design that we was using was a tube with the same thing.
Yep.
So we decided to try and fill all that to make sure that couldn't happen in our cable.
And as I look at it for design, I've got a protective conductor on the outside, so I can see that protective conductor there, but around the line and neutral, or positive and negative, depending on what it's being used from, there is actually a plastic wrapper, but that's not wrapping the protective conductor. The protective conductor is on the outside. What's the thinking behind that? Why we got that protective conductor on the outside?
So the protective conductor on the inside of this sheathing, the red sheathing,
Okay.
is a metallic tape.
Okay, so there's a metallic tape in there, so a metal tape which is connected constantly to the protective conductor.
Yeah.
And what does that provide the cable with then? What sort of properties will that give it?
So the tape on the outside itself, it all builds up to the fire performance. So we've got the silicon, which is the ceramifiable bit. You've then got the tape, which is another fire barrier, and then the sheathing on the outside is then another barrier. This one inside is just to make the strippability easier. So it makes the sheathing strip off easier. If I show that again.
Right, so that's why that pulled off so easy, because we haven't got any. Look at that.
It just sliding over.
Yeah, as you twist.
And protecting the silicon makes it slide over.
Right, okay.
And then terminating wise, you can just give that a pull. So that'll come down. We don't have to strip that with cutters.
Yeah.
It's thin enough so you can just pull it.
Okay.
And then you're done.
And what I've seen before is where you've got, say, a solid tube in there, what ends up happening on the end of it can be quite sharp when you've ringed it around with a knife, and what happens is these silicon conductors here rub against it and can give you a fault, therefore, to earth, can't they?
Yeah, when
the screen earthed.
original, going back many, many years, when the original design came out, they used to use like ferrules, so they'd slide them over.
They did, I remember doing that.
You remember doing that?
I remember doing that, yeah. Because of that reason.
If it makes you feel any better, that was before I got into this industry.
Right, okay, yeah. Doesn't make me feel any better. Because you're probably saying, yeah, I was so young at the time when you were installing. Okay, so again, by having this, by design then, we remove that chance of snagging against the film, the foil, whatever you're going to call that. And it's also earthed. Does that make this a screened cable as well then, does it? Is that how it works?
Yeah, it is classed as a screen. So in ours, we make sure that we lay these together. It's one of the benefits of it. So we're twisting the cores.
Yes.
We've got a really tight earth continuity between this CPC and the screening.
Which is inside here, which we saw, yeah, inside of the tube, yeah.
The twisting is then giving it strength and body and allows better data transmission. That's why twisted cores are used in data cables as well.
Makes sense.
So there's a lot of features and benefits in the cable that are just a bit different to all the other cables in the marketplace.
Which I didn't know any of those things. So that was absolutely fantastic. If you're watching this as a learner and that's news to you, it's also me, having taught for 19 years, it's news to me as well. Now, what would be great is if we could take maybe a low smoke cable and we could take a PVC one and just set fire to them and sort of visually demonstrate what sort of smoke comes off it. Is that something we can do, Aaron?
We have a small controlled environment where we could do that task.
Right, let's bring that footage in because this was great fun. It's fantastic here at Doncaster Cables. We've got control conditions. We can actually set fire to a piece of twin and CPC cable, and you can see instantly there, Marcus, that black smoke, can't you?
Yeah, you can, and it's not something you get to see every day, is it? It's been quite an experience to do this under control conditions and see the byproduct of twin and CPC cable actually burning. So.
Yeah, so see that there, we're on fire, not a lot of cable, but look how much smoke it generates from such a small piece of cable. Imagine a whole run was on fire. Now we're bringing the white, low smoke, non-halogen, is that right?
It is correct, Gaz, yeah.
So when we set fire to this one, obviously we're off and running, same distance from the blowtorch.
Yeah, and you can already see the reaction is different compared to what we've previously seen with the twin and CPC.
I'm struggling to see any smoke. I know it's low smoke, but look.
Yeah, it's very hard to notice, isn't it? Especially on camera, tiny bit. But again, you look at the difference, and especially if you're in a certain type of building, the difference that's going to make in terms of if there was a fire. So we've just seen Gaz and Aaron, okay, looking at a genuine product, okay, from Doncaster Cables that goes for all the approval and the British standards, etc. that is needed. We're now going to look, like we said at the start of the show, and I'm quite interested with this bit because I haven't seen them yet. You said you got some fake cables. What do you mean by fake? Are they made of rubber? Plastic?
Some, we've had all sorts in the past.
Right.
So I think it's important for the college learners to know the marketplace. Yeah. So we're not trying to scare learners or anything else, just educate them about the market. So the industry, what they say in the industry is 1 in 5 reels of cable is either faulty, substandard, counterfeit or fake.
Oh, really?
Which is a massive
As
number.
high as that, yeah. I wouldn't have thought that would be as high as that.
So that came from the Approved Cables Initiative, and they did all the work.
Yeah.
And some of the samples that we've got here is from that time where people were testing the marketplace, and the ACI were taking samples from the marketplace. And it's just to highlight what can happen. And people need to trust where they're procuring cables from, or trust the manufacturer. So this one here, as an example, this is a 4-core 70 square millimetre cable. And this is from about 8-9 years ago, I believe.
Yeah.
But if we look at the cable itself, we'd ask if anyone could see what there was. The eagle-eyed people, if they really know, might say, well, the core sequence is wrong because it should be blue, brown, black and grey, and it's not. But that's not the real issue with this cable. So you need to bring in a real 70 square millimetre cable to be able to see what the problem is. If you just got this one delivered onto site, you would be installing that and you wouldn't really know that was any issue.
You wouldn't, would you? Because you'd be especially busy at work as well. You wouldn't necessarily be looking at the first fix stage at that point, would you?
No, and then when you actually compare it to a proper 70 mil, you can see the cross-section difference.
Yeah.
This cable...
The physical size of the cable is different as well, isn't it? It's, there's a, when you actually put them side by side, you can actually, and obviously I passed you both, and straight away you could feel sort of the difference in quality as such, especially of this outer PVC insulation. So,
yeah, if you only had the one, you'd then be wondering, you would just install that because it says it's the right one. And the whole range of this one led to a public warning being issued by BASEC, which is the British Approval Service for Cables. So they issued a public warning because this manufacturer had made 50 mil but printed it as 70.
oh, okay.
And then they'd done 35, printed as 50, and 25 printed as 35. Oh, wow. So they did the whole range, and they were selling the whole range of size.
And like you said, how many electricians, when installing that, would actually know? You wouldn't look at that straight away and think, unless you're using this cable all the time and you get that, you might think, wait, there's something's not right about this. But if you're maybe an apprentice or something like that, and you've just been asked to first fix it, then you might be none the wiser as such.
No, and that's what happened with this one. So the only reason this came to light is from a trade show when a lug manufacturer got some quite heated complaints from an installer saying their lugs were rubbish.
And it was actually
because
the
they
cable.
were falling off of the cable, and the cable was the bit that was the issue. So that's one example. That's quite a big one that was in the marketplace. The Approved Cables Initiative website then, there's some other ones. So if we looked at this one here, which is sometimes quite difficult to see, but this is cheating on a process, really. So this is a flexible cable. Within the FLEX standard, you have to have a FLEX test, which is so many cycles where the flex is moved over some pulley wheels. And this manufacturer here had skipped a process which actually twists the bunch wires together. So that twisting motion gives all the structure to the flex.
Yeah.
But they skipped that process, and then as this cable flexes and wears out, this live copper wire, so this is a single strand of copper wire, has now come out of the sheathing.
Pops out the side.
Really for someone to touch hold of that and then get...
It's like an ingrown hair, isn't it?
It is, yeah. So that's another
great
big example.
Again, and it's obviously very important when we're selecting our cables, and you know that we understand that, like yourselves, Doncaster Cables, the cable of choice for electricians is everything's BASEC approved. You've got a laboratory that goes through. Just me visiting Doncaster Cables, you can see that a lot more goes into it than what maybe we appreciate as electricians on site.
And we try and get involved in the colleges to try and give the people who are learning that education that they have a choice when they get into the market. The market is massively dominated by imported product. So 80-85% of all cable installed is imported from overseas. And there's a small percentage left which is manufactured in the UK. And
you're one of that small
percentage. And we're one of that
small percentage, definitely. And there's something to shout from, isn't it? You know,
it is.
Produced in the United Kingdom, serving electricians in the United Kingdom, isn't it? So, have we got any more?
The last one we've got to show, this one's my favourite actually. So there's two very...
I'm excited. You got me excited for that.
Two very similar. So this is manufacturing the sheathing compounds. So you can cheapen the grades of compounds. So this is an Arctic grade flexible, which is not Arctic because this is after the cold bend test.
Oh, okay.
So we put it in a freezer and we bend it around a mandrel, and this.
And I take it shouldn't look like that.
And it shouldn't look like that. So it should look fully intact. So on site, if that got to freezing conditions, it wouldn't break down. And then this is this has not been in the freezer. This is just a normal cable. So if I take this green yellow out, this is someone going to the extreme of making the cheapest possible compound that they can. And to the stage where I can actually get that green and peel it off.
Oh, wow.
I call it the cheese string effect.
Yeah.
But you can just peel the green off.
See, because I've got no nails, I eat a cheese string whole. So, yeah, so. But look at that. You should never be able to do that, should
And
you?
if we can bend that, it doesn't take any effort whatsoever, just to completely expose.
And if that's in the inside of the flex and you've bent it round to clip it nicely, actually what you could be doing is causing a problem inside, and it's not until you go and test you actually find you've got an issue with your insulation resistance maybe.
Yeah, so these are extremes, but it highlights what people can do. So people can make choices to make the product cheaper. It's a massively competitive market, especially now it's more imported because a lot of the buying decisions are driven on price.
Yeah.
And we want to stand aside from that as a company and give people a reassurance that the product quality, reliability
Is all there. Yeah.
Fascinating.
Yeah.
I would suggest.
Cables.
Yeah.
Again, like it's eye-opening for myself, you know, working on site that actually these products exist out there.
Yeah.
Yeah.
Just can't get over it. And again, you know, when you see it, you see it. The undersize one, whether people can on the camera really see it, when we're here, you physically can see that is a different size of cable. It ain't even close, is it?
No,
So they're dropping it down from 70 to 50.
Yeah.
Yeah, and from 50 to
I
35.
seen one the other day, so on a social media post for like a forum, someone actually had first fixed a property, okay, in twin and CPC, and they'd gone to second fix and there was no CPC in there. Yeah. So they was not happy.
So whole first fix?
Yeah.
No protective.
As far as I know, it was a whole first fix. I just had a look, seen a bit of it, and they couldn't believe it.
Takes you back to the 70s when there was protective conductor in the lighting circuits, all plastic. But yeah, to have that would be a bit of an issue. Well, it's been a little bit different. We're not live streamed. We've tried to leave it live, so you'll still get the stumbles and fumbles as you've been watching through this. Exactly, I talked when other things are on and stuff like that. But we'd like to thank those people that make it possible for us to get out 12 times a year to colleges. And we're on the road again. Kirklees College is happening in March.
Yeah, the 27th of March to be exact.
27th of March, we're going to be at West Suffolk College doing another live stream.
We are, yeah.
And we're seeing Ben Ship when we get down there. But we would like to thank once again the great people at Schneider Electric, Wallbox, Wago, Marshall Tufflex, CNORM, Doncaster Cables have been genial hosts for us today.
They have been amazing.
Test Instrument Solutions, the Lasico Group, and Marshall Tufflex, okay, for... did I say Marshall Tufflex? Metrel even. So Marshall Tufflex are on there as well, so I apologise for
I'm happy
them.
you did that because I've always wanted to say one of the brands who support us.
Right, well, you can
because
do
I'm
from
thankful as well.
Oh,
so
okay,
so
so
I've got Metrel in there. So.
Okay, even though it's Metrel. Okay, but never mind. Never mind. We'll
You
try to...
You said Way goes Fargo? Yeah. I thought we was on that bandwagon.
Yeah, it's Knipex, not Nipex. We could go on forever, can we?
We
And we
could,
probably would.
Yeah.
So we'd like to thank all those people that have helped us. We've got one more rig to look at they've got here, and there is a spot, the deliberate mistake. And we're not going to say what that deliberate mistake is. We're going to take a look at the rig on the wall that homes in on the EV Ultra.
Yeah.
We'd like you to leave it in the comments what you think they've got wrong here as well. So let's go over to the wall. So if I bring that one in.
So we've got an install where the EV Ultra cable has been used.
We have.
And you can see here that one of the twisted pairs has been used for the CT clamp.
Well, that's tiny, isn't
Okay,
it?
it is, yeah.
Look how big that one is.
Yeah, but you can see here, just again, a generic installation where they've brought in the power to the charger we've got over here on the wall, and then this super screened Cat5 cable has been used in conjunction. We've got no Copex coming out of there for an extra data cable or anything like that, or a Cat5. It's all enclosed into one. Makes it a lot easier for us electricians to install.
Do we give these towers a wiggle, see if they're the 19 cores? With your expert fingers, are they 19 cores?
Oh, I don't know. I don't think so.
Okay.
They seem a bit stiff. Yeah.
Okay, so we're some.
I don't think there's been a lot of current through these ones.
No,
either.
not over the time. So as you look at that job there is a deliberate mistake. Aaron's left it on there. He uses it as part of his college connections he does here at Doncaster Cables. See if the students can spot it, which is great. But obviously we can see how that EV Ultra cable hasn't been used fully because obviously those ones are still there. Might be a CT for solar in the future.
Yeah.
You've got the options of doing that as well. So, okay, pretty good. Right, let's go back to our seats. If you...
Do you think they'll get it?
Yeah, learners that watch this are really clever people, so they will get that. So for the stream that we've just done, okay, that didn't go out live, that hopefully finds its way onto YouTube at some point, we'd like to thank Doncaster Cables for being fantastic hosts for us, as well as all the people that have supported us in order to get out to these. And like we said, we're back on the 27th of March, and we're at West Suffolk College seeing Ben Ship and the great learners down there. So it's a college for that one. It's a college also in April.
Yeah.
So please leave all those comments below, and I'll let you get back to them this time, Marcus. You want to get back to all those comments?
I'll get back to the comments.
Okay, so Marcus will get back to all of the comments.
It's been quite weird, hasn't it, without a live audience?
Yeah, we did it in front of a live
almost
audience.
feel more nervous now there's not people there. It's strange. Yeah.
We could just have done with a bit of internet earlier
We could
on.
have, yeah. Yeah, we had a few technical issues, so apologies for that.
It wasn't our fault, though.
No, no. You
See,
did say at the start of the day as well, didn't you? If it goes wrong, it'll be a technical issue. Yeah.
We'll see you on the next live stream, 27th of March.